Perfect.
Hello, everybody. Yeah, you're sharing the saga. All good. Thank you. Hello, everybody. Good morning if you are in US, or good afternoon if you are like us in Ireland. Artificial intelligence in health and fitness is the topic we are talking about today. Yep. Sagar, we can go forward. And my name is Svitlana Samko. I am technical project manager, professional Scrum master, founder of W2business Academy for QA developers and mentor there. You can see we have some QR codes here, and we will have during our presentation as well. Please join us on LinkedIn.
Hello, guys. Thank you so much for having us today. It's a privilege to present such an audience. I'm Sagar Saxena. I'm currently doing my PhD in explainable AI in ML Labs, TU Dublin. These are a few of my areas of interest. So I'm interested in explainable AI, time series data handling, and I'm also an enthusiast about neuroscience. Extracurricular as well. I'm a competitor in CrossFit Games, fittest man on earth. I'm also a coach and a motivational speaker. Again, like Svitlana, if you want to connect with me, that's my LinkedIn.
So today we will use some framework. You probably heard about it before. It's build, measure, learn. So we will share our data with you, propose you some ideas, and measure our knowledge, your knowledge as well, if you would like, about AI and both topics we shared with you today at the end. Thank you.
Well, so let's get started just to bring everyone on the same page. So there are three major types of learning that happens in AI. So they are maybe classified into supervised, unsupervised, and semi-supervised learning. Today, we'll be just focusing on the supervised aspect of things because of the time constraint. So let's move on with the supervised learning. So there are two major types. That's the regression and the classification tasks. And on the left, if you see, if you have a set of features, and for the supervised learning, you need to have labeled data. So each of those data should be labeled. And depending on that input data set, you create a data set and you input that to an architecture, say a neural network, for example. So after the neural net gets trained on the data, you create a trained model. So, and now when the model is ready, you put some testing data for the model to get a generalized aspect of things. And that's where generalization happens, and see if the model is performing well or not. The model infers real numbers, so that's a regression task. And if it says classification, say class A or B, COVID positive, COVID negative, and it's hot or cold, that's are all classification tasks. So these are two major types of supervised learning.
So there are three major factors that influence the advancement of AI in healthcare, and it's deep learning maturation, localized compute power via GPUs or TPUs, and large labeled open source data sets. So as example, ImageNet is providing this, so it's available for everyone, data set that you can use in your application. And what kind of reason we have for machine learning or artificial intelligence in healthcare? Let's take a look at that graph, and we can see that radiologists in 2016, just to let you know, had to work at least one person, at least for 12,500 people. We can see different countries like India, Ethiopia, Tanzania. It was not possible for them to cover this amount of people. Lots of data to look through is a concern and reason for AI in healthcare, limited human expertise because it's hard to cover all the needs, and reduce bias and human enforced errors is very important part. So there is no bias in sex or origin or any other biases if it's ML or AI.
So relaying across the same point, so focusing on the healthcare, there are the few case studies, so they may be segregated into, with the application of AI in healthcare. One is relevant to identification of images, say for diabetic retinopathy, where you scan the retina and understand the person has diabetes and may hurt the cornea or not, or cancerous cells, right? If it's a tumor or benign tumor or malignant tumor. So deep learning models like convolutional neural nets are being currently used quite efficiently in that. And on the other hand, there are other sets of models like GNNs, that's graph neural networks, that's also been quite prevalent in the recent past. They have been used into drug discovery, identifying patterns within patients, so understanding which patients have similar history to get treated with. So that's the rationale behind electronic health records, EHR, and also for drug recommendation. So there was one of the papers where they had mentioned across invention of COVID vaccine, they used something similar to GNNs to make the vaccination process faster and scan through different genomic types.
So as you can see on this image, and as Sagar mentioned it before, difference between benign and malignant tumor is a subtle and difficult pathology problem to be solved using deep learning. And it's hard for the human eye to identify it. But if you will use machine learning, it's easier and it is more efficient.
And again, relevant to the same supervised problem that we started off stating, and this, like, one is the image data, another one would be the time series data. So for example, if you are having this ECG monitor, you would see that there's a sequence of waves. So those are all time series data. Here is an example of a PPG sensor where it had captured a person at rest or walking. So PPG sensors are normally the sensors that's being attached to the smart watches like Garmin, Fitbits, and relevant to the same. And they capture this data. So in the next slide, we would see how this data capturing is happening. So this is an extraction example where you're not only collecting data, but gathering the intelligence. So from the Fitbit or Garmin, the data is being captured. A lot of signal processing is happening behind the scenes. So for example, Fourier transforms or Laplace transforms to convert the data into frequency domain. And then from that, intelligence is being extracted from key metrics like what's the VO2 max, what's the heart rate, and then depending on the assessments that's been made on the process data, some UI is being generated and being displayed for the end user. So this is a typical PPG functionality. It's a sensor. It's underneath your smartwatch, or also something like Whoop smart bands. It also have similar aspect of working principle, where the light is emitted from the photoelectric sensor. It goes within your subcutaneous skin. The dermis hits the capillary vessel and reflects back. So depending on this reflection principle, the photodetector, it is able to understand how the blood is flowing within the body, and depending on that, it captures the data and analyzes it. This is a typical case study where ML is being used in healthcare specifically for blood pressure prediction and recommendation. So if you see on the left, the vital and the behavior and the contextual data is being provided. And depending on that, the data is pre-processed, typical machine learning pipeline. ARIMA model is quite prevalent for time series data. Some pre-trained models are used. Feature importance using Shapely, it's one of the state of the art for understanding feature importance, and it provides a prediction depending on the current state. So if the person wants to improve the blood pressure, they also generates a report. Okay, your blood pressure is currently this. If you augment these changes like walking at a particular speed, or if you do running, it can be beneficial for you. So this is typical example where machine learning can be used to predict and recommend certain aspects in healthcare.
So there are some products here presented using artificial intelligence in fitness. Some of them were analyzed by us, and they are mobile and web application. Others are smart equipment. Mobile application or web application is something that you are usually installing at your mobile or laptop, and this application is using your camera. When I'm doing some squats or any push-ups, the application is analyzing in real time, are you doing it right, in proper way, the most optimal way, and is proposing you some better solutions if the angle is wrong or you are doing anything wrong that could be improved. Smart equipment is something that you can install in your house. And this application, this equipment, can check your goal. So you are providing your goal and can check, should you increase load, decrease load, what should you improve, to achieve your goal. And also some real people are there as well that can provide you some consultations. So some trainers are available, coaches are available there.
And as per the last point that Svitlana mentioned, and most of these approaches uses something of a computer vision side of things, where it's an object detection and anchor detection. So there are these anchors across the skeletal structure. It's a general model that's being already created, and depending on that, you have to match yourself standing in front of the camera. So once they analyze that and fixate that, and then depending on that, they give you certain aspects of things, if your movement pattern, posture is wrong or not, corrective postures. Mostly OpenCV is being used this in Python for such tasks. Moving on, an experiment we conducted, to test how AI can be used for personalized drug recommendation system. In particular, that this was not with the mindset of replacing doctors, but therefore to make an informed decision about the patients. For example, if there's a patient 30 years old, has some headache and is a male, needs a drug to alleviate the headache, and wants the drug should be at least 4.5 rated all over the world, over-the-counter drug to be precise. This application that we developed would help the person to get a drug name relevant to the same. This is the particular pipeline that we adhere to and we were able to achieve during the experimentation. So we had the data collected. It was quite noisy. It's an open source again. A lot of pre-processing was done. Some natural language processing was done. And then features were extracted. A model was trained on, and we got some results. So as the best results that we were able to get was 76.5% accuracy. So with 76.5% accuracy, the model would be able to provide you a drug that would have all the constraint validated. So these are the future potential directions that we propose here. So most of the fitness trackers today are focused on aggregating data over the period of 8 to 24 hours, right? What if they are able to provide a guideline to increase the volume and intensity of training to reach a desirable goal? For example, say you are an athlete and you are aspiring to be selected in national team, but you're also working in the software industry or any other, say you're a researcher or you're working in academia, and it's a very hectic schedule. So what kind of training do you need to adhere to so that you'll be able to attain that level? So that's where such kind of machine learning approaches could be used to predict a regimen that would cater to your needs to achieve a certain goal, depending on the biomarkers that's being recorded by the PPG sensors and other sensors that may help them to do.
So here, if you could use your mobile, also I will provide you some link that you can have in chat. That is the last part of the presentation, which is measuring the knowledge. If you could use it, you can find the form there. It's very short. And after this presentation, you can measure your knowledge. Thank you very much. Do you have any questions?
Thank you so much for your time today. I appreciate that. We are happy to get some questions answered.
Okay, thank you very much. If anybody has some questions, you can either put them in chat or just let me know and I can let you speak. And as we're waiting for those, I did want to ask, this week we had, I think it was this week that came out, the report on how AI modeling didn't really work for COVID. I'm sure you read that report. Do you have any comments about that? Especially how it applies to maybe some of what they've discovered applies to what you're working on?
Yeah, so I'm currently working on other sides of things. So this is a side project that along with my partner, we are working on the same. Coming to the point where you mentioned about and that relevant report where AI didn't work for COVID, the point is AI is a tool that's data centric. So it also depends on what data is being fed into such a mechanism or a set of algorithms. If the data is fraudulent and biased, we can't expect a magic to happen. It will be able to get some data, some inference out of it. So I don't want to jump my guns and provide an inference because I'm not too aware what the entire process was behind the scenes. But I would still say that AI is just a tool. We can't expect it to answer all the queries that humans even don't have answers to. If our natural neural network, the human brain is able to create an artificial neural network. So if we are able to provide an inference to a certain task, using AI, we would just remove the biases and any human enforced errors that would be there and fasten the process. But again, coming back to the point, I think the data may not be quite effective. Also, the amount of machine power that was used, you have to also see about the timeline, how much of the timeline was provided for these algorithms to work on. I'm just a proponent of development here, so I wouldn't focus on just the negative. Something that's a failure, but there's a probable chance. Even if you take the example of AlphaGo, right? The AI was not able to work at the very onset and provide the best solution and be the best Go player in the world. It was a reinforcement learning problem, and it took millions of times. You have to iterate through the same thing. So the first time, maybe the report, it was not able to provide a relevant outcome relevant to COVID. But you never know, if we try it next time, it may give a better output. So yeah,
I would also, yeah, thank you, Sagar. I would also add quickly that one of the problems was that everyone wanted to be, a hero and to create the best solution, and instead of working together on one solution. And I think a lot of people are saying that this is one of the first crises like this, and we may see something similar in the future. So I think it's a good test for us as humanity, and we should try to work together on one solution, one big solution, which will gather the data from all over the world and improve the result instead of working on one application for every part of the world or every developer or everyone. So better to create one or few good solutions that we all will work on together.
Yeah, thank you. That was an interesting point that they made that researchers are in competition, I guess, right? And as much as they don't want to be, they have to be, and so that yes. Makes collaboration interesting at times.
Yeah, that's true.
Okay. Well, one last call. Did anybody else have any questions? If you can put them in chat. No? Okay. So again, thank you very much, Sagar and Svitlana. I don't know if you're going to stay for the rest of the day and join us for the after party at 4:35 our time. That'd be great. I know you won't be able to make it probably to the party at Fort Lauderdale, but maybe some other time. We'd love to see
you. We hope to be there in the US. Yeah.
Okay.
Next time.
No, thank you very much.
Thank you so much. Take care. Have a great one.